Alrighty, so where we left off last time was we have worked on basically implementing the queue system for our viewer game app, and we've created a manager which manages an n number of queues for every single streamer, and then we have a supervisor that manages the managers because I don't know if that file is still open here. Yeah, so the plan basically was that at some point we were going to have like expiry on those queues, because at some point, there's not enough messages coming in. We just want to make sure that we free up some space. Or there is also a mechanic of like pausing or like temporarily disabling a queue. I don't really know. So that's why we have a queue manager that can create queues for streamers. And then that manager manages a bunch of queues. For now, that's just how we're gonna make it work, and then we're gonna hook it up to an endpoint so we can actually use it. And then we could possibly eventually hook it up to our Twitch bot, and then we can try it out, like connecting the Twitch bot together with the Elixir app. And then I think the next step after that is to maybe host this thing and see how it actually performs. Maybe get some metrics in, see how those queues are going, because there's a lot of cool stuff that you can do with those supervisors and like the tools that Elixir and Erlang give you in like a way of managing these processes and whatnot. So for now, let's just continue on with the guide that we have and the guide that we followed. This is like from the Elixir website. There's just the basic getting started guide, which is very thorough, which is very, very, very nice. They have like the normal basic stuff. So like what are processes? How do you spawn them? Some more like Erlang-like basics. How do you do recursion? What about the file system? How do you touch those protocols? A lot of these things we've actually skipped by diving deep or like diving straight into the code. Maybe eventually we'll get back to them. But for now we're basically rolling with whatever we have, which is working good enough. Where we left off though, so we kind of skipped agents because I just knew about GenServer, so I just started with that. But agents is basically just a simplified state manager. It's like a simplified GenServer that it's an abstraction on top of GenServer that you can just have a bunch of state and make updates to it using a simple API. What's up, Luna? Just came in and had a KFC ad. Now I despise you. Do you? Wait, what? Sorry, Luna. What time is it for you? Isn't it like super late? Isn't it like every time we talk, it's like 4 a.m. for you? Because I was like, wait a minute, talking about KFC, isn't it like dinner time for you? But it's like 4 a.m. 3 a.m. How are you doing? If you guys haven't checked Luna out, please go check her out. Amazing streamer, which I don't have enough time for to actually watch. It's like every time I watch streamers not live, time that I have, it's probably time zones. It's 3:30 a.m. Why are you awake? God damn. Okay, so we've had supervisors and how you hook them up to applications. I think this is where we ended last time, and this is also what is represented in the code. So we have an application, we registered the supervisors, and we registered the name so that we have only one supervisor that we can refer to by his name. And I think at some point we will replace the GenServer manager here that we have with something called a DynamicSupervisor, because I think that's what it said here somewhere. Although in this chapter we first implemented a supervisor, it's not the first time we used one. In the previous chapter, blah blah blah, we used the one in test. We're not done yet. So far we've been supervising the registry, but our application also is also starting buckets. Since buckets are dynamically, just like our stream, like our queues are made for a streamer, but like every single like streamer's name is like dynamic, could be infinite amount, right? Like you can have millions of streamers and thus millions of queues, or you could just have one streamer and it's like one queue. So there's not a fixed amount of supervisors here, or a fixed amount of queues here that we need to start. And so since buckets are started dynamically, they have to be supervised by a special type of supervisor called a dynamic supervisor. So let me first just recall what their abstractions were. I think they had some sort of bucket that you could put items into, like a basket sort of. And then they had a registry and then a supervisor. So this is like the exact abstraction that we have. Like there's an application. The application starts the supervisor, the queue supervisor. The supervisor starts a manager, and then the manager, so in this case it starts one registry, and then a registry contains an n amount of buckets. That's like their abstraction. And for us it's like one manager is maintaining n amount of queues for every streamer. Sub-Zero, how's it going? It's simple. I'm a DGen. DGen hours, let's go. All right, let's get started with dynamic supervisors then. So we've now successfully defined our supervisor, which is automatically started and stopped. That's basically what we did with this. So when it crashes, it reboots, and the same for the manager. All right. Okay, let's just take a quick stab at the manager. So our manager is doing start link. So remember how our registry is both linking via start link and monitoring via monitor. Here. No, this is destroy. Here, process monitor. So when you create a streamer, we're creating a monitor and we're storing that monitor. So yeah, we had two states basically. We had the queues and then we had the monitoring references per queue. Links are bidirectional, which implies that a crash in a bucket will crash the registry. Right, so if we have a manager running, if one of the queues crashes, the manager crashes. Oof. Which means that it loses all of the queues references and all of the monitoring references. Oof. That means if one streamer's queue crashes, all of the like queues are gone, which is bad. Big boy bad. So I guess that's what this dynamic supervisor is gonna fix. In other words, we want the registry to keep running even if a bucket crashes, and let's write a new registry test. Okay. Let's go there. Manager test. Removes bucket on crash. Oh, wait, yeah. Removes queue on crash. Yeah, let's do that. So we have the manager again. For those of you that can't remember what tests are, they basically you describe what it's supposed to do, and then you write code to assert that the thing is doing what you're thinking it's supposed to do. Which means that if you ever make changes to your code, you can guarantee that the behavior is still working as intended. So like you're describing what the program is supposed to be doing. Otherwise, you have to test it manually every time. Like when you make a change, you need to then like make sure that all of these cases are still covered. And that's a lot of manual work and it takes a lot of time. So We're programmers. We like to automate things. So for example, for the manager, we cannot get a queue if the queue is not created. We cannot create, or we can create and get queues. So it says that we can, you know, create a queue for a streamer, and then we can get the queue for a streamer. We cannot create a queue for a streamer that already has a queue. So when we create a queue and then we call for the same streamer another queue, it says it's erroring out. So these are like assertions that help me protect like that my work is, you know, okay. But we don't have a test that if like a queue crashes, that my manager is still alive. So it's a very good idea to actually do that. So let's write it, manager. Let's create a queue, just like we've done before. Just for our cats. And then we don't assert anything. So we create a queue and then we look up the queue, but we already have the queue, so for us it doesn't really matter. And then we stop the bucket, crash the queue, and then we assert that if we look up the queue, in this case we are doing manager get queue for just our cats. So let's make it a variable here, streamer, just like here. Bada bing, bada boom, and then here, just like here. Error. Do we want this to be a tuple? Error. It should be like doesn't exist, right? That's what we asserted. Cannot get a queue. Oh. Cannot get a queue when not created. So our assertion was that this is just returning error, so error. But like, let's say we do two. Let's say we create two queues. So one for just cats. We should keep the other one in. So this test should fail. So like, let's say we do streamer one. So streamer one should error out, but streamer two should be fine. Like that's what we want to test. Like we can create two like queues, and then we can, I guess we can test beforehand that they are there. So we can assert that the queue is okay. And this one as well. Q1, Q2. Don't really care about these. Oh, we do actually, do we? No, we don't. And then we stop Q1, and then Q2 should be still okay. I don't know if this test will work, but let's give it a shot. Mix test. Can't remember if that's how you run it, but there was something like mix test, listen on standard in. TCP connection, localhost database connection connect. You guys reaper cannot be. Oh, sure. I didn't know my test needed a database. Invalid use of blah 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 online 28. This one, that's what I thought already. Yeah. Q final. No. Yeah, I can do. Yeah, it's fine. This should work. Yeah, so exited in no process. Process is not alive. Because the application is not started. Yeah, so you can see that on this assertion on 27. Yeah, on test 27, it's already failing because the whole manager crashed. So instead of like giving us an error, it's like it just completely exited. It's just completely broken. This is great. So now we have a test that proves and shows that our code that we have today is not working. Like we've created 2 queues, like streamer queues. We asserted that they were fine in the beginning. We crashed one of them, and then instead of erroring and giving us an error, like I couldn't find this like streamer, I couldn't find a queue for the streamer. Instead, it just says the whole fucking app just crashed. Like the whole manager just crashed. So if a queue crashes, the manager crashes, and if a manager crashes, then all queue. So the manager holds the state for all of the queues.
Yo, happy birthday, Void. So proud to be part of this community. Hope 34 suits you.
Yo, welcome back to the guest community. Thank you so much, Gulish. Welcome back to the 62 centuries in a row of resubscribing. Welcome back to the Cats community. I love your programming streams, Boyd. It excites my 2 brain cells. It's pretty difficult to comprehend, understand. 2 brain cells, and slowly one will die just watching the stream. But if you remember, Zero, in our manager code, we hold state here. Is it really your birthday? No, it's not. We hold 2 states here. So like this is just like a data structure. Let's think of it this way, right? Let's think of it this way. Like we just have a list here, and then somebody calls create queue, and then what we're gonna hold is like Princess Looney Tunes empty list, right? So this is one queue. This list is a queue. Is one instance of the queue. And then somebody says, okay, I want to create another queue for a streamer. So I'm like, okay, just cats gets a viewer game queue. But so there's another queue. And so what we said here is like the Luna's queue, we exit Luna's queue. Right? Which means that this one is dead. So let's just represent that. This is like a timeline. So this one is now dead. But instead of handling it gracefully, this whole manager is dead. So like, instead of handling it gracefully, this is now just one big X. And then what we said, we told the supervisor, that if a manager crashes, that it should do a 1-for-1 strategy, which means if the manager crashes, reboot it. And when you reboot something, you don't want to reboot it with all the error code. You know, like you want to start with a clean slate. You don't know what was in that process that crashed it. So like we could populate it with the same state, but that would likely to crash it again. So what it does is basically you tell it 1-for-1. So like if I had more processes running here that it was managing, it would say if this manager crashes, only restart this manager. But there's also like a strategy. You could say like, if one of these crashes, then restart all of them. But in this case, it's just one. So it's like, if this process crashes, restart it. Which means if we restart a process, it will call init with this. Empty thing and empty this. Which means that in the end, where was this blank file? Here, it just starts with empty again. So we've lost, for example, Boyd's queue, which might have had like a crap ton of people just waiting in line, like Bob Ross. Bob Ross wants to join VR games, you know? And so it's a nice thing that like we told the supervisor to do its job, but like now that one of them crashed and like it didn't handle it gracefully, now the manager crashed, which means that it wiped my entire state of all of the queues of the streamer that this manager was managing, and the references that it holded, the monitoring references. So now we have a test that represents that, which is nice. So as you can see here, it says like removes the thing on crash, and it shows like GenServer call, boom, no process is alive associated with his name, and it didn't do this. Oh my god, Mom, I'm on TV. 34 and looking like a daddy. 34. Would you believe if I said I was 34? It's funny because my manager just had a car accident. Now Boyd is making him crash again. Oh boy. Hope he's well. Jesus. So the test is similar to removes bucket on exit, except that we are being a little bit more harsh by sending shutdown as an exit reason, instead of normal. So, oh, we already have a test for this? GenServer stop. Oh yeah, so right. So if we do stop, it is fine. Like that thing is fine. But when we do shutdown, it crashed the whole thing. Okay, interesting. So if a process terminates with a reason different than normal, all linked processes receive an exit signal, causing the linked process to also terminate unless it is trapping exits. Right, so because the manager is doing here, let me see, where does it start here? Start link on a queue. So we create a queue for a streamer, like we start a link instance basically of like a queue, and we store that inside of our, you know, our state, and inside of this is in this state. If any of the underlying processes dies that are now linked to this upper manager, they will also die if they're not shut down with normal. That is important. Elixir brings back memories from when I programmed in Erlang. Wait, you programmed in Erlang, Zero? Oh, damn. I mean, this is on top of Erlang, so I didn't know that. You're reading this? Looney got a little crush on you. This is your chance. Ask her out. I wish, man. I wish. But Luna lives on the other side of the planet. It's a little bit far. Let me see. Where are we? So when the bucket terminated, the registry also stopped and our test fails when trying to do a gen call to it. Yes. So we're going to solve this by defining a new supervisor that will spawn and supervise all buckets. Opposite of the previous supervisor we defined, the children are not known up front, but they are rather started dynamically. So instead of, think about it like this. Remember that our manager, sorry, not the manager, the supervisor. Remember that the supervisor has a bunch of children that it manages, like a child processes that it manages. Let's say it just, for every queue, it would start one of these, like these things, and we can have a strategy for them, one for one. So if one, in this case, queue dies, we just restart only that queue. So like for Luna's queue would start empty again, which is like, you know, it's fine. If the app crashed, if the queue somehow crashed, that's like the best thing you can do. You know, you lose all the data, or maybe you persist the data into some data store somewhere to make sure that you don't lose everything. But in most cases, you just want to wipe out, you know, what you had that was causing the crash. But since we don't know the children up front, we cannot register them. So we cannot do this for dynamic children, but I think that's where the dynamic supervisor comes in. It's like we create a dynamic supervisor, which like supervises the queues. So instead of having a manager do that, we can have a dynamic supervisor like supervise these queues, so that we can have a strategy for them that if one of them dies, you know, we just restart it. My queue is so empty, like my life without you. That's so cute, Luna. That's so cute. Wait, you can provide for her and fly her out. You can live a happy life. True, true. But here I am, in my room, programming queues like no tomorrow. I know the emptiness in your work focused heart is eating away at you. Jesus, ghoulish. To write a poem. Let's see. Since Dynamic Supervisor does not define any children during initialization, the Dynamic Supervisor allows us to skip the work of defining a whole separate module with a usual start link function and init callback. Instead, we can define a Dynamic Supervisor directly in the Supervision tree by giving it a name and a strategy. Oh, I think I know what we're gonna do. Okay, my gut feeling is that by giving it a name, so we start a Dynamic Supervisor with a name, we're going to be referencing this name within the manager to link the queue. So like we're going to start, you know, we're going to start like adding it to the queue from here. Like we're going to start a new queue from within the supervisor. That's, I think, what we're going to do. So like our manager, I don't know what our manager is going to manage, really. I don't know if that manager is still going to exist, thinking about it, but yeah. So Dynamic Supervisor start child, you give it the bucket supervisor, and then the bucket you want to create. Or the module, yeah, so the GenServer that you want to create. Interesting, okay. I think I can make this work. So what we're gonna do is we're gonna create a Dynamic Supervisor. We're gonna name it viewer games .queues.queue supervisor, and then strategy 141, comma. Remember that the name of the process can be an atom. So far, we've named processes the same name as the module that we defined in implementation. For example, the process defined by KV registry was given the name KV registry. This is simply a convention. If later there's an error in your system that says process name crashed with a reason, you know exactly where to investigate. Gotcha. I can name this anything. I can name this Bob. And it, you know, creates a supervisor referenced by the atom Bob. But for now, we're referencing it to Q supervisor. And since we already have Q's alias, we can just do this. In this case, there's no modules, so we picked the name bucket supervisor. It could have been any other name. We've also chosen one for one strategy, which is currently the available strategy, the only available strategy for dynamic supervisors. Gotcha. Cool. Now it tells us to just try it in the REPL. You know, that's fine. And then we do dynamic supervisor start child, and then we give it the supervisor, which is in this case viewer games dot queues dot queue supervisor, and then the actual queue. So viewer games dot queues dot queue closing. And then I think we need to reference it. So we give it OK, and then we get the queue. And then what we can do is we can do queue dot, I don't know what the methods are on queue. We see that. Queue. Sorry, it's like alias, viewer games, queues, queue, queue dot join. And we give it the queue that we just created, and then the name. So like Bob Ross joined the queue. And so now if we do queue dot players queue, we get that the list is now Bob Ross. That's the only player in the queue. Sweet. And so if we create another queue, so now if we do okay. Last step is to change the registry to use the dynamic supervisor. Yeah, see, this is what I thought. Dynamic supervisor start child, and then you create it from here. So this is created in that bucket, but you can still reference it inside the, so the manager still holds a reference to the process ID. Yeah, okay. This makes sense. I was right. So like this is still the same. The monitoring is still the same. It's just, it's hold, instead of hold and linked to this manager, it is linked to this dynamic supervisor. So like this needs to be removed. And in theory, you could keep the code the same. And we can just do this. Dynamic supervisor, and then queues. Is this alias somewhere? No. Maybe we should. Yeah, maybe we should. So we do queues dot queue supervisor, and then queues dot queue. So in theory, this is all the same. Like this is a queue, this is a queue. In theory, this is not a queue, this is a PID, but like that's just how we do it. Bullish won 1,000 points in roulette and now has 60 points. Sick. Bullish is only winning, what the hell? That's insane. So I think only changing this will make everything else work. Map put, name PID. Isn't that what we were already doing? Wait, what? Monitoring reference, monitoring refs, map put, new state is the combined version of the both of them. Yeah, okay. We're good, we're good. That is enough to make the test pass. Right. Hope for the best. Hey, nice. Let's go. Wait. Let's commit this. That's really pog. Mix lint. Mix format, I think is what it is. Cool. Make sure that if a sub-process fails, we don't lose the manager. Really should set a cooldown again. Also having the bot a reminder every X amount of time about the points and gambling system could make a cool active chat activity. This is not my bot, by the way. This is just Stream Elements because I was too lazy to reboot the bot. The Arduino, like fuck, what was it called? Not the Arduino, but the Raspberry Pi crashed, and it was corrupt somehow. So I needed to reinstall Ubuntu on it, or like some random version of Ubuntu that has Docker on it. That's a lot lighter. But I haven't actually, you know, rebooted everything and redeployed the application there yet. You call your plants your babies? No. I do give them names though, because the app told me to do so. Yeah. Yeah, I can set a gambling cooldown, yeah. People can do whatever they want in the chat. I don't really mind. If you want to gamble your heart away, that's just what it is. I don't mind. If it really becomes a problem and people feel like they cannot chat, they can just let me know. You don't have enough points to roulette. Feels bad. However, when the supervisor restarts the new bucket, the registry does not know about it. True. That's actually true. Because then it gets a new PID, but this dynamic supervisor does not notify the manager of it. So like we will know that it crashed and we will remove it. So like here, handle info. Oh no, this one doesn't have need this anymore. Because this one is not linked to the other one anymore, but it does do a process monitor, so not entirely sure how that works. But I think because they're not linked anymore, they might not receive the message. So we will have an empty bucket in the supervisor that nobody can access. To solve this, we want to say that the buckets are actually temporary. If they crash, regardless of the reason, they should not be restarted. Okay, but I don't have an agent. Can I do the same with GenServer? GenServer restart temporary. Modules deprecated. Goodness, is this really what your night is gonna be like? You have 3,677 points, so you're gonna gamble with 10. Just because you're going too fast, the bot does not register it. Nice. Okay, let me see. Is there any way I can tell the GenServer that it's temporary. I don't really know what it does. I don't really understand it. When the supervisor restarts the new bucket, the registry does not know about it. So we'll have an empty bucket in the supervisor. Oh, right. So like we clean it up in this manager. We removed the reference because we were like notified that a process died and we care about it. But the supervisor just thinks it needs to restart it. Why don't we just update our reference to the new thing? So like we tell it here it went down, or like restart. I don't know. That's weird. You can test that it's set to temporary. Let's see if this works, you know? Are temporary workers tested that they are temporary workers? So this is in the queue test. Queue is set to temporary. I just want to see if it works. You restart temporary. This test will fail. You gotta go low after you win. This is how you avoid losing your money in casino. But yes, this is exactly what my nights are gonna be like. Okay, I will know for sure that I will add a delay. Maybe I just need to just like maybe I'll just need to add just a delay for you, Ghoulish. Maybe just for you. Okay, the test failed because it's like the key restart was not found. Okay. So I don't think this will actually exist. I think this is only on agent. But let's just see if it works. So this is use GenServer, restart temporary. Mark. Okay. I don't actually know what this does. It uses GenServer and it gives some parameters to it. I don't know like how that works. Let's Google it. Maybe we can find the source code. So when you use, you basically gain all of the powerful functions that this module had. Like you just inherit all the methods. Which means you also have restart. And since agent is built on top of GenServer, use GenServer also accepts a list of options which configure the child specification and therefore how it runs under a supervisor. The generated child spec can be customized with the following options: ID, restart, and shutdown. How to shut down the child, either immediately or give it a time to shut down. When the child should be restarted, defaults to permanent. The child specification identifier defaults to the current module. For example, use GenServer, restart transient. What does that even mean? Kortstondig. Voorbijgaand. Still doesn't really tell me anything. Shutdown after 10,000, what is it, milliseconds? Shut down the child. The child process. Child process. Child process. Not talking about real children here. Parent and child. I only lost like 2k net right now. Can make it back, I promise. I won't lose the house. I can fix it and provide you and the kids. We're shutting down the parent. We're shutting down the parent of the child. Of all the debt. All the debt. Transient means it's short-lived. But isn't that what temporary is? Or maybe it's just alias, you know? Restart. Child spec. For example, when restart is set to transient, the supervisor does not restart the child in case it exits with reason normal, shutdown, or shutdown term. Ah. I see. Do I really see? I don't really know. My gut feeling is transient is like both on normal and shutdown. It will just, you know, not restart the child. On temporary, it will restart it on normal. And then when it's like forcefully crashed, or it's like completely fucked and completely broken. Temporary and transient are basically synonyms. Transient, temporary, ephemeral are roughly the same in the English language. Yeah, but the question is whether they're also in here the same. Okay, there are different options. See restart values section below. Okay, here we go. Permanent, the child process is always restarted. This is a default. The child process is never restarted, regardless of the supervision strategy. Any termination, even abnormal, is considered successful. So temporary is the one where it's like, you know, this is like the most hardest way of like making sure that this is never restarted. And this one, the child process only is restart only if it terminates abnormally. Yeah, okay. Okay, yeah, so I was right. I was just flipping them around. So transient is when it terminates normally. This one when it terminates abnormally. Cool. Wait. Sweet. Cool. Cool. Wait. Okay. What's next? I'm happy that we did this little deep dive. Okay. So we've added a test that just tests that that's, you know, that's like the supervisor child specification. Cool. At this point, you may be wondering why use a supervisor if it never restarts its children. True. Why? Why is that a thing? It happens that supervisors provide more than restarts. They are also responsible for guaranteeing proper startup and shutdown, especially in the case of crashes in a supervision tree. Okay. The assertion should pass now. Yeah, we already had that, no? Oh no, yeah, we already had that here. when we added the KV bucket supervisor as a child of KV supervisor, we begin to have supervisors that supervise other supervisors, so-called supervision trees. Every time you add a new child to a supervisor, it is important to evaluate if the supervisor strategy is correct, as well as the order of child processes. In this case, we are using 1-for-1, and the KV registry is started before bucket supervisor. One flaw that shows up right away is the ordering issue. Since KV registry invokes KV bucket supervisor, then the KV bucket supervisor must be started before the KV registry. Otherwise, it may happen that the registry attempts to reach the bucket supervisor before it has started. What? The second-hand productivity. Me not knowing anything what is going on. Nice. That's it. That's good vibes, Hummus. Appreciate that. Second-hand productivity. Feel free if you like. I don't know. You don't do codes. The only codes I do is busting encryption. That's pretty big, actually. That's pretty big. What do you do? Why do you need to bust encryption? You a hacker? Okay, let's see. This encryption puzzles. Tell me about it. I don't understand. Like, I've never heard of that. Encryption puzzles. The second flaw is related to the supervision strategy. One flaw shows up right away is the ordering issue. Since KV registry, right, so for us that's the manager, supervisor, because the manager is started before the dynamic supervisor, the queue supervisor. It may happen that the registry attempts to reach to the bucket supervisor before it is started. Right, because we have code in the manager that references the queue supervisor and thus needs to be started. But that might not be the case because we're starting this one before this one. The second flaw is related to the supervision strategy. If the KV registry dies, that's the manager. All information linking KV bucket names to the bucket processes is lost. Therefore, the KV bucket supervisor and its children must terminate too. Otherwise, we have orphan processes. That makes sense. These two are using each other's, like this one is using this one's state, or at least its child processes. And so if this one terminates, this one should too. And if this one terminates, the manager should too, because if this one terminates, that means we don't have any queues and we have PIDs in the manager that don't really, work together very well. That makes sense. In the light of this observation, we should consider moving to another supervision strategy. The two other candidates are 1-for-all and rest-for-one. A supervisor using rest-for-one strategy will kill and restart child processes which were started after the crashed child. In this case, we would want the bucket supervisor to terminate if the KV registry terminates. This would require the bucket supervisor to be placed after the registry, which violates the ordering constraint we have established 2 paragraphs above. So our last option is to go 1-for-all, which is the supervisor will kill and restart all of its child processes whenever one of them dies. This is a completely reasonable approach for application since the registry can't work without a bucket supervisor, and the bucket supervisor should terminate without its registry. So let's re-implement init to encode those properties. So this is one for all, and then we order it differently. Puzzles similar like the puzzles the Ivy Day brings out every year during Christmas. I actually don't know anything about that. Interesting. So rest for one would mean that if we do it this way, if the manager crashes, only the children below it would get restarted. Sounds unreasonable to me. If one child dies, kill all the children. I'm not sure if you're just like what facing because of the fact that it's called children, or whether you're what facing because the strategy does not make sense for our supervisor processes. I don't know whichever one you're referring to. If you're referring to actual children, then yes, that's kind of wood phase. If you're referring to the processes, I would say this makes sense because they're interconnected. If this one dies, we actually want this one to die because we want an empty queue again. Like we want empty queue supervisors. If the manager crashes, if the dynamic supervisor crashes, we want the manager to like restart because we need, if this one has no state, no children anymore, that means that this one is lingering on to state that it doesn't make sense. And if you're telling me like the fact that if you're just telling me that the strategy is wrong for these processes, I can show you why I think it makes sense. Killing everybody today. Programming wise, it is reasonable. Okay, fair enough. Okay, cool. Cool. And we're good. So far, we've been starting one registry per test to ensure that they're isolated. Since we now changed our registry to use Bucket Supervisor, which is registered globally, our tests are now relying on this shared supervisor, even though each test has its own registry. The question, should we? It depends. I hate those. I hate when they say it depends. It is okay to rely on shared state as long as we depend only on non-shared partition of the state. Although multiple registries may start buckets on the shared bucket supervisor, those buckets and registries are isolated from each other. We should only run into concurrency issues if we use functions like DynamicSupervisor count children, which would count all buckets from all registries, potentially giving different results when the test runs concurrently. Since we have relied only on non-shared partition of the bucket supervisor so far, we don't really need to worry about the concurrency issues in our test suite. In case it ever becomes a problem, we can start a supervisor per test and pass it an argument to the registry starting function. Makes sense. What's up, Lavra? How's you? Now that we've defined our supervision tree, it is a great opportunity to introduce the observer tool that ships with Erlang. Start your application with IAX as mix. Okay. Let's do that in a new window. Oh, we have a typo. Oh, we have a comma missing. Tests are passing, right? Cool. We don't really have a supervisor test. But yeah. Make sure that make sure that queues are never restarted to avoid lingering processes in the dynamic supervisor. Cool. Make sure that if the manager or / dynamic supervisor crashes, we restart both to make sure that state does not get out of sync, because both rely on one another. Having the dynamic supervisor crash causing all children to shut down will cause the manager to have PIDs in state that don't actually exist anymore. Having manager crash will wipe all the references to the PIDs and the monitoring, having the application not know about any queues, while the dynamic supervisor still holds on to these processes, orphan processes. Cool. Hope that's clear for future Boyd. I'm good. Been stuck in a book. How are you guys? What book are you reading? How much? You should do a stream. I don't know if you stream, but you should do a stream of these puzzles. I'll be very interested. I think that would be cool. Just call me a nerd, but like, very interesting what it is. Okay, so we have defined our supervision tree. It is a great opportunity to introduce the observer tool that ships with Erlang. Start your application. Oh, I've seen this. I've actually seen this in a talk. This is insane. Look at this. This is insane. Like I already said last stream, it's actually funny because this doesn't really work that well. The fonts are not like perfect and all, but maybe I can, change it. The cool thing is that I already told you that Erlang VM really, mimics a lot of the concepts of an actual computer, like an actual operating system. So there's processes and PIDs and all that stuff, but you can see that you have also the graphs as if it's like an actual thing, and you can look at all of the supervisors managing sub-processes. So our queue supervisor right now is not managing anything, but you can see that our repository is managing something, a process with the PID 395, and our endpoint, web endpoint, has spawned a bunch of processes that are listening. There's like a pops up supervisor. I don't know what this is. Garbage collection, I don't know. Endpoint config is supervising something. But like if we now create some queues, the queue supervisor would show that we would actually have this. And the coolest thing is you can even interact with them. Because you can see the PID, you can see like all of the different things that have been booted up in the application that are defined in the mix file. So extra applications here, and then there's sub applications and stuff like that. But this is really cool. You can see the state even. See, stack trace. You can see the state of the actual process. It's insane. Like if you need to debug something, you don't need to console log and then put the app in the same state. You can just open the debugger, like this Erlang debugger, and just check the state of this thing. Like what is this thing currently holding in its state? It's insane. It's beautiful. This is so much power. And you can see our manager is not holding anything. It's just two empty, what was this? Maps, empty maps. And you can see that's exactly what we told our manager to be. On init, we hold two maps, queues by stream and monitoring references. It's freaking amazing. So if I now, oh, you can even, oh, okay, you can filter it too. Like if I now say Viewer Games, oh, that's just, yeah, this is the whole Viewer Games app. Okay, yeah. This doesn't really work though. Oh, it does change. Sometimes. It's just very slow. Okay, it does change. It just doesn't really want to change. Okay, so let's create a queue now. Alias viewer games dot queues dot, yeah, let's just do queues, and then we do viewer games queues dot, how did we manager that exists, right? Because I think we supervise it with a name. Use supervisor manager. Yeah, manager. Dot, I don't know why I did viewer games actually. I can just do queues dot manager, and then we can do create queue. Queues dot manager, and then just draw cats, or just do it small. Okay, we now have a PID. And I think it should now show up. And we can see it only show up here, but if we inspect the state, we can see that this references to a PID here, which is then the PID of the specific GenServer that is here, 7092. So these two are linked. The state of whatever is in manager is just rocats dynamically to this, and a monitoring reference to just rocats here, which is exactly what we meant. This is awesome, and I can even kill this. I can kill the process here. And then it just restarted, and now the manager should be empty again. Yep. So it cleaned it up. So what have we... So we just lost that one. Let's just do... Okay. Q1 equals this. Do another one. Q2. 0. PRS. Okay. So now we have two queues. If we refresh, it also auto pulls, but yeah, so there's two now. And then let's say we do queues dot queue dot join Q2, because we want to join, you know, zero's queue. So Bob Ross joins the queue. We can now see that zeros now has Bob Ross inside the queue. And if we kill mine, kill, I have no idea what's gonna happen. This should only remove me. And the state is still there. So it killed my queue. I killed my process, but the state of zero's queue is still there. But if I kill this whole queue supervisor, for some reason, now the manager's restarted. Beautiful. And that's the power of this thing. It's like you write your code and you want it to fail. Like you don't want to write your code full of, oh no, my internet's dying. Okay, we're back. I don't know why my internet just died. Okay. Like, Elixir and Erlang's philosophy is, as a programmer, you cannot know everything that happens. So just let it crash. Erlang, let it crash. It's an actual term. Elixir. Let it crash. The Zen of Erlang. Let it crash. It's interesting. It's a different philosophy. But because of the fact that we're doing everything in processes and we're handling it gracefully, our other parts of the application are not affected. You know, like me writing a bug into the queue, and then my queue, like I know it's like JuzzerCat's queue accidentally got into the state where it broke. It did not accidentally also crash Zero's queue. It didn't accidentally crash the manager of the queue. It didn't actually wipe that state. It just like, you know, the manager and the queue are there. And if then in some shape or form, this is very unlikely, but if the supervisor crashes in some shape or form, you know, we're handling it too. By just making sure that the top level, you know, supervisor does not crash. But, you know, sometimes you write code that just crashes. We all do it. We've all handled bugs before where we working with like a fucking 10-year-old application and the state of the data is completely as like unexpected. Maybe the database was not properly formatted and there's null fields for stuff and like columns are added, but like all data did not get like a value for this, and you assume as a developer that this value is there, and then you write your code in such a way that you think this value is there, but now it's a null, and you call like something on a null value or nil value, and now boom, your queue blows up. It happens, but it's okay. You find the bug, fix it. The rest of the application is still fine. This is cool though. I didn't know that you can easily boot it up like this. And the most interesting part is you can probably use this in prod. You can probably just hook this up to a prod system and inspect the state of the system to debug something in prod. Like, how did this thing get into a state? And you can see all the things that it called too. I can see the exact things that this process has done to get into this place. I can see the whole stack trace of what it has done. In this case, that's not a queue, so let's just create a queue again. It's done nothing right now, but let's just make it do something. Let's join the Q1. Bob Ross. Oh, it still doesn't do anything. Rip. Oh, it's still old state. It still doesn't show anything. I don't know how this works. I also don't know what this dictionary is. You can see how much memory this uses. That's cool. Cool. Okay. What's next? At the end of the day, tools like Observer are one of the reasons you always want to start processes inside a supervision tree, even if they are temporary, to ensure that they're always reachable and introspectable. True, because if we didn't do that, we would have something like this, just the manager, and that's where it ends. It doesn't show like the sub processes. Actually, I'm not entirely sure. If we did start link, whether it would show up here. Probably, it probably would. This is also interesting. This is a dynamic supervised or dynamic processes that spawn other processes. So maybe this is like start link, like in the manager. Like we called it a name here, but you can also just not name it. Now that our buckets are linked and supervised, let's see how we can speed things up. Ooh, I'm liking that. ETS. Every time we need to look up a bucket, we need to send a message to the registry in case our registry is being accessed concurrently by multiple processes. The registry may become a bottleneck. We will learn about ETS, Erlang term storage, and how to use it as a cache mechanism. Don't use ETS as a cache prematurely. Log and analyze your application performance and identify which parts are bottlenecks, so you know whether you should cache and what you should... Wait, to know what you should cache and what you should... So you know whether you should cache and what you should cache. Okay, I was like, is this the same sentence twice? This chapter is merely an example of how ETS can be used once you've determined the need. Hold up, what is this? ETS allows us to store any Elixir term in an in-memory table. What? When creating an ETS table, two arguments are required: the table name and a set of options. From the available options, we pass the table type and its access rules. We have chosen the set type, which means that keys cannot be duplicated, but we have also set the table access to protected, meaning only processes that created the table can write to it, but all processes can read from it. What the heck? That is so cool. ETS.new buckets underscore registry set protected. And so since it's created inside of the IEX process, I can insert into it. But like other processes, like my sub process, cannot actually look up this table. Interesting. Be aware that if you read-write call violates the access control, the operation will raise argument error. Finally, set and protected are default values. We will skip them from now on. Can I insert my process into you? Wait, that sounds actually so weird. That was a terrible one, Luna. You can do better than this. I believe you. I think you can do better. Okay, we create a new table called buckets registry. We insert who with the current process, current PID into the buckets registry, and then we look up the buckets registry for the PID. Let's change the KV registry to use ETS tables. The first change is to modify our registry to require a name argument. Chat, what? Do we want to do this already? Without accessing the server. What do we wait? What do we do before? Here is a GenServer. Start. Fetch. Looks up the bucket PID for name stored in server. What? Whoa, I didn't know this existed. What's that? Lookup. With the same interface. Get queue. This. Oh. So instead of doing GenServer call server with this fucking shit, we call the table that stored the data in memory. But I thought this was also in memory. I don't understand. But it's because this thing has program code, like code in front of it. I don't really fully understand like how much faster this really is. Maybe it's because here it's using the messaging system. As if you're like calling it from outside. You're just like, hey, GenServer, you know, do this, run this event. Rather than, hey, GenServer, find me something that is in this table, and then I'll give it to you. So then he the code was removed for the get call. Oh. Okay, let's do that. So this get call is removed, which is doing all this. Lookup. Get streamer from blah blah blah. So now what we're gonna do is we're going to be taking it out of the ETS table. And then we need to store the table in here. So we'll get the server here. Options. So we get the server by name. And instead of doing OK, we do server. And then in init, we store the server. Table, yeah, table. So on init, because this is the initial like stuff that gets passed. Init, we get the table now. And then we create a new table on init. And then oh, we only use it for the queues. Okay. Read concurrency. Named table. I don't know, bro. I'm so confused. Okay. First, pass the name to the GenServer's init. Second of all, look it up from ETS instead. Okay. Let's do that. This syntax, I don't really know what this is. Let's just, you know, just copy it. So this is ETS, do a lookup on for the given server. And since our server is like just PID, yeah, so this is like not PID, this is like the reference atom of the server. Whether it's PID, in this case it's like this name right here, this atom manager. You use the manager as the table name, so this is just another atom that we pass as ETS lookup, and then we pass the streamer, and then I don't know what this is. What is the caret elixir? Understand the pin operator. To understand what the caret operator does in Elixir, you have to understand what equals does. In most languages, equals assignment operator. You want to assign the value 1 to a variable a. Depending on the language, you're going to write something like a equals 1. The value on the right side is assigned to the value on the left side. But in Elixir, equals isn't an assignment operator, it's a match operator. The match operator is the heart of one of the most powerful features of the Elixir language, pattern matching. I know this. I know this equals sign already. Now that you understand what pattern matching is, you will have to look at the pin operator. Remember the two effect of pattern matching. It matches the value on the left side with the value on the right side. If it matches, and if the left hand side includes a variable, it assigns the corresponding value from the right hand side to the variable. Yes, this is great, but sometimes for reasons, I just want to make sure what I have on the left side matches with what I have on the right side, without any assignment in case I have a variable on the left hand side. In any words, if you just want to compare both sides, I just want to compare both sides. This is exactly what the pin operator does. Ah. Interesting. We pattern match A and 1. So A1 is assigned to A. Then we pattern match A with 2, but we pinned A on its value 1. So Elixir returns an error. It's like as if we had a mismatch, 1 is not equal to 2. We show the previous example again. We have a list and we're comparing the list. It is a list, it has 3 values. And these are variables, so they get filled in. X is 1, Y is 2, Z is 3. If we do X, Y, and Z for the list 4, 5, 6, you will get a no match on the right side value. While if you do X, Y, Z, it will just overwrite these variables. Aha. That is good to know. So oh my god, that is actually super good to know. Holy shit. Because in our tests, I'm doing a lot of like extra line breaks and then comparing the two values, and there's doing like Q1 and Q2, you know, like Q1 is this thing, or like, okay, Q1, blah, 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 is do expression. And then I do a Q2. But in reality, what I want is I want to pattern match it with okay, but then Q1 of do expression 2. So like, let's say we do a create Q here, and then we do a get Q. I just want to make sure that I pattern match whatever this get Q gives me, is that it matches with Q1. You know, don't overwrite. Mello, thank you so much for the raid. Holy shit, how was your stream? Yeah, if you guys did check Mello out, please go check her out. Mello raid. How was life? How was life? What do you stream nowadays? I just know that you have like some like sort of ASMR channel sort of thing going on. I'm not sure if that's just YouTube. I didn't know you did like streams as well. Gave you a follow though. So this is useful. This is very useful. Yo, Freeze Chills, thanks so much for the follow. Sup King Lowland, how's it going? Sup Freeze Chills. Jim, welcome. Cyrian, hope I pronounced it correctly. Maybe it's like something completely different. Maybe it's like XY Rian. I don't know. ASMR is only on YouTube, and then just normal gaming stuff on Twitch. I see. Nice. You stream, like the streaming on Twitch, is that in English or in Dutch? But welcome, Raiders. How's it going? My name is Boyd. I stream, you know, I stream on Mondays. I just do video games, but on Wednesdays I do Tech Wednesdays, which is, you know, programming stuff or soldering or electrical engineering or whatever I think is like interesting. But yeah, Dutch because my English sucks. I see.
Get in here!
King Lowland, thanks so much for the follow as well. So I would completely understand if you like don't enjoy watching coding streams, or like, oh yeah, I don't really understand anything. You know, I still appreciate you guys stopping by. It's just a lot of nerdy stuff, so I keep that in mind. So we just learned that this pin operator is basically saying match whatever comes out of this this function call, try to pattern match it with this, which means a list with a tuple with, on the left side it should match with the streamer variable that we had here, and on the right side it's an empty variable which we are setting, so like we can use that somewhere else. So we're not pattern matching really on this one. This is just like we just expect a value here. And then if that's the case, so if this pattern is met, then we return okay with the PID. Actually, this is very interesting for me since we're going to game development / design study next school year. Wow, that's actually really cool. Game development, on the other hand, though, is like using a completely different language, but that's cool. That's cool. Which side are you gonna pick though? Like game development or designing, or is it just gonna be like just figuring it out first? I'll just check you out when you're not streaming this coding stuff. All good, King. Appreciate it. The course offers both. You can chill and feel smart while Boyd does all the work. True. I mean, it is kind of like puzzling, you know? I'm also learning a lot. This is not my like go-to language, you know? This is not my language that I do for my job, for example. So we're learning all together. So basically what we're saying here is we're only handling two cases. We're handling when there is a list and it has something in it, or the case where it's an empty list. And if it returns anything else, then it just breaks. Then it just blows up. It says there's no matching pattern here. So what coding language is this? This is Elixir. Elixir language. It's a functional language, so it's completely different from what you were gonna do, but programming is still programming. So yeah, I like this song actually. Piano songs, it's my weakness. Okay, so we now have some sort of table that we can store data in memory. We initialize the manager with this table name, which in this case is just this process here. So this process here is then passed to, we create a new table, we tell it that it's a named table, and then we can read from this concurrently. And then we still also have state in our manager, which is the monitoring references, which we're not storing inside of the data table. And then on getQ, we're reading from it. So that means we can remove the whole lookup call. We don't need that anymore. And then as for destroy, there's still some things to be done. But we are doing a lookup, right? Map get queues by streamer. So this also needs to change, but that is okay. Let's just keep this as is for now. Our tests are gonna fail, but that's okay. What's my job, since this is a completely different side of programming than my direction? So my job is a developer team lead. But I'm using like the languages that I work with are Go, PHP, a lot of front-end work because I was originally a front-end developer, so a lot of JavaScript. But I'm pretty much doing a bit of everything. I use Python in my work too. But yeah, mostly like object-oriented stuff. So that's like what you're probably going to be finding in your game development. A lot of object-oriented programming. But this is a functional language, so that's different. So there's, for example, no classes. Okay, this is a module, but like there's no real state. It's like everything is passed to the function. Except for this. This is like global stuff. Okay, so we've learned that. We create a server that's still the same. So creates is still the same. Destroy is still going to be using GenServer call. But the getQ call is going to be fast because it's like, it's not doing the outside GenServer call. Okay, and then we have the previous handle call has been removed. Create. So we need to read from. We need to read from the thing, but we can use getQ for that. So here we say map has key. We can just do getQ. Streamer names. So it's okay. Hold up. We're storing. What does this return? A PID of like the table? Oh god. New? ETS. Erlang docs are so much harder to read. ETS new T. So okay, so this, what are we getting here? What is this? Because like here in the examples, they're also not storing it. They're just like named table T, and then they're referencing T every time they do an insert. I really don't know where I'm looking, but this is interesting. No, I completely understand. I completely understand. Like if it's like this is also very strange for people that do program. So I wouldn't even be surprised if like this would be completely like crazy if you're not programming. What's up, GBRRLP1? Thank you. Welcome to the stream. What language is this? So I'm looking at Erlang now, but the language that I'm programming in is Elixir, which is built on top of Erlang. So we're using an internal like low-level module now, which is from Erlang, which doesn't have the abstraction in Elixir. Probably because the code by itself is already pretty straightforward. Probably. I don't know if they ever will abstract this in some shape or form, but I think the abstraction by itself is already okay. In my opinion, though, you know, I would be fine with having like some sort of like table or something. But this is like how they're gonna roll it, so it's fine. Or like memory table. You know, abstraction would be kind of cool looking. But it is what it is. So this creates a new table. But I just want to see what T is. It just has a T. Oh, okay. So I see. So if you were to not name it, you could also just get it from here. So you get a reference to the table probably, or like, so maybe a PID. And then you can reference that in your insert call. So it will be able to find the table. I see. Init. New. Here, new. TID or atom. Yeah, so if you pass a name and then you tell it named table, you will get an atom back. So in this case, this will be our table. And so like, in theory, we can do this and we can return it here. And so now, this will be the table. And we can do this if we want to. Or we can just do this. Either way works, I think. I'm going to head off now, but I'll definitely come back later if you're still live or another stream. Have a good one. Thank you so much for hanging out, Freeze, and good luck with your studies. Or good luck with your... Wait. What did you call it? Wasn't like... Yeah, so school. Okay, studies. Yes, okay, I was good. Whew. Saved. I was just like, wait, was it like a course? Or was it like school? I don't know. Either way, good luck. Hope you find the thing that you're looking for. Game design and game development is really cool. There's a lot of very low level things, and I think actually, to be completely honest, you will learn a lot by doing game development, because there's a lot more optimizations that you need to do when you do game development. And so with software development for websites or web servers or stuff like that, APIs, like business sort of stuff, things can be, it doesn't have to be that performant. You don't have to like write like the most performant code. It needs to be like maintainable and readable and that kind of stuff. But for games, stuff needs to be very, like, you have 60 FPS to work with, Within those 60 FPS, you need to perform all the calculations and everything to keep your game running. So like if your process is slower, then the 60 frames, or like the processing that it needs to render out those frames every like 60 frames per second, then your game will suffer. And then the fact like different CPUs all the time, Like as software developers, we most of the time, like if you run something in the cloud, you know like what machine you're running it on. You can just upgrade your computer. Like you can just talk to Google and tell them like, hey, upgrade my server, pay some more money, and you get an upgraded server. But if you're doing game development, you're running it on client machines. Nobody knows like what kind of machines people have at home. This is kind of random, but can you do a Kermit the Frog impression? No, I cannot. Gotta code your game in assembly like roller coaster like RC2. Is this RC2 like a roller coaster? No. Why do I think roller coaster? What is RC2? RC2 game. Wait, what? What is RC2? So did you mean Roller Coaster Tycoon? This project is sick, by the way. This is really cool. Indeed, game development is a pain in the ass, but fun. I think you will learn a lot, like that you won't learn in the web world. And I think it actually comes down to a lot of the same principles, because if you're developing like game servers as well and having interaction with networking for your game and stuff like that, you will also touch like clouds and concurrency and scaling of nodes and like making sure that, you know, like the uptime of your game server is like matters, you know. And so yeah, I think game development by itself is very, very cool. I think you can learn a lot, but you have to, you know, there is a cost with that. You'll learn a lot, you'll work very fast, but that's also the problem. These like game development has high pressure, you know, like there's deadlines for games. There's big game events that games need to be there, you know, like there's not a lot of game development like companies that actually postpone their games like often. And so yeah, it's a very fast place, I would say. Okay, let's store it. So let's see. This confused me a little bit. So we can do a lookup and we can, oh yeah, okay, you know, this is fine, okay. No, this is, I'm not confused. Okay, so what we get here is a ref, table ref, or maybe we can just do this. I don't really care. I think this might be better though, just to say overwrite the table and just like add table or PID. Table ref. Cool. But maybe this is not clear what is going to be in the table. So then maybe we do put it back to queues by streamer. Wait, what? We don't pass queues by streamer there. We pass the server. Wait, what the fuck are they doing? Lookup. Lookup. Server name. Server name. Oh, but because in our case, our table name is the same as our server name. Oh, this is so confusing. How do I make this? Oh boy. Server. No, this is so confusing. What? It's like we're creating a new table, but the table name is the same as this module atom. And so like when I'm referencing this, when I call get queue, it's actually the server. Because it's the same name, But like if that were to change, you know, then you don't know, whatever. It's fine. It just happens to be the table. Table. But then table doesn't match server. What do they do? Names. Names. Lookup names, even though it says lookup server. Okay, it's fine. Or do the same. Cool. Search the queue for a streamer, and then we do a case statement on this, and then we say if the case is okay, PID, we don't care about the PID, then what we do is, oh god, all of that work actually. In the case of error, so when it doesn't exist, okay, yeah, so in the case of when it's okay, we are going to say reply with this. Oh, they still have it as a call, as a cast. Okay. Should we make it a cast as well? I don't think we should. We just make it synchronous. Fuck the world. We'll just keep it as is. Okay, so if it's error, then we do all of this work. And then we need one more end here. Yeah, so we do a get queue call to see if this streamer is already in the queue. This will do an ETS lookup, and it will return as either okay with the PID or error. Oh, but that changes how we operate actually. So this should be error. What did we have in our test? Queue test. We need to comply with our test, because otherwise our method doesn't work. Manager test. I think we just saw error. Okay, cool. Meanwhile, Cyberpunk 2077. I think that's a good example, you know, of like how a high pressure environment does not really, you know, produce the output that you want. Okay, so this is correct. Kind of a weird how it differs from the rest, but that's okay. Okay, so we do handle call for create. If it's okay, then we do reply. If it's error, then we create it and we add it to the thing. But we will need to actually add it by doing an insert in the table rather than doing a map put. So do you participate in hackathons? I have actually, yes. Hackathons? I guess. I've participated in like startup weekends, for example. Which is pretty fun. Pretty fun stuff. Queue. Hold up, no, this is supposed to be here. Insert, ETS insert, streamer, queue. So we say key value, just like map put. And then, because we just insert, I don't think we're gonna get a result back. So maybe our reply is not so good. Or we need to do a lookup again, but let's see what ETS insert gives us. Insert. Gives us a tuple. No. True. Okay, so it doesn't give us actual things back. So for the sake of our tests, what we would need to do is do another lookup. So get Q, what gives us, oh, but it gives us PID. Wait, what? Oh, that's correct. Yeah, that's correct. No, that's correct. Okay, so we would need to then do, okay, Q again. No. Oh shit, what do we need? We need to not find one, we need to find all of them. No, wait, we don't need this anymore.
Everyone,
We don't need this.
get in here!
Because we don't store the state in here. Yo, Ryan, thank you so much for follow. What's the end goal of this project? So the actual end goal is to be able to have some sort of platform that people can manage their viewer games. And we were actually pretty far already. But then I decided to like change things up a bit and use some of the more Elixir core principles. So that we can buy ourselves some time to actually think of the proper structure. So instead of like storing all of this in like the database, let's just store it in memory. And then when it crashes, you know, like it is what it is. I just want to see how people use it. Maybe nobody's going to use it. Who knows? Maybe Luna will use it. I don't know if Luna does any viewer games. I don't know if she needs a queue. Okay, so since we don't actually store the new queues in the queues here anymore, what we need to do is we need to store this queues by streamer in here, and that's it. Yeah. Need a queue for boyfriend applications. Exactly. That's how popular she is. Names. Yeah, it's the same. Names. Yeah. Cool. Okay, but then for the destroy, we will also need to update it. So here we find, in our monitoring reference, we find the streamer. We find the monitoring reference, we delete it. Like we stop the queue. Which is okay. If I stop the queue, it will not restart. Then doesn't it just get a down message and just get deleted? Do we really need to do this manually? Don't worry, yours is still number one. Aw, thanks, Luna. Appreciate it. But you're still kidding, so now it hurts. Now it actually double hurts. Let me see. We've got new monitoring references. We delete the monitoring references, which makes sense because we don't want lingering monitoring references. And then I think we can just stop it. I don't think we need to clean anything up at all. Because like when a process crashes, we would get a message to then just wipe it. Wait, so yeah, here. Delete it from the ETS table instead of the map. So that's what we need to do. So map delete should be ETS. I think this can just be gone. Holy shit. Luna, thank you so much for... Oh, I just guilt-tripped her into gifting a sub. Thank you so much for gifting a sub to Hummus. Welcome, Hummus, to the Cats community. Thank you so much. That's really nice, Luna. Thank you so much. Oh, that's awkward. The moment that you guilt-trip someone into subbing. Great stuff. Okay, this needs to be a lookup too. get queue streamer. If okay, no, if what was the other one? If error, then just reply with queue not found. If not, then it should be okay with the table. But do we care? Error queue from the created queue, PID. Yeah, so this would be PID. We use the PID to then we get the queue, kill the queue. We kill the queue, and then we say okay with the queue, and then we give it new state, which is just queues by streamer. And ooh, okay. Just because we need to update here. Ooh. Please forgive me. You know what to say. After gift sub comes a date. Already gave before and still no date. Yeah. Big sad, big sad. Sorry, Luna. Sorry that I did you like that. Force you to gift a sub. It's crazy. Maybe it is okay to just keep the still reference, because maybe let's try it out. Let's try it out. Maybe this is okay. Maybe we overcomplicated things last time. Because if we just stop the GenServer. Oh, I think we said we did this because of the fact that
well, when life gives you
hold
lemons.
on, what am I doing? What am I doing? Oh my god, Luna. Luna, no! Luna, thanks so much for gifting a sub to Zero as well. Welcome to the Cats community. Oh god, Luna, stop. Stop wasting money. Luna, it's way too late. Wait, it's like 5 a.m. almost. Crazy. Chad is brainwashing me. Luna, please. Oh no. Luna, go to sleep. Your DGen brain is like, during this DGen hours, is like just forcing you to spend money. Do we have that? Wait, do we have that credit card emote actually? Hold on. I don't think I added that one. Absolutely love that one. That credit card one. This is how Pokemon seems to be. Oh. Sick. This is what I feel like for Pokemon. It's true. It's true. Been spending so much money on Pokemon. It's crazy. I think at some point we're gonna get married, but you know, she just doesn't know it yet. Fucking Lavra. The changed emotes. Okay, we have new queues by streamer. This is where we just do an ETS dot delete queues by streamer. Easy. And then we just say same reference here. And then we have new references. We can just override it, you know, like let's just fuck the world. Where before I was just doing new something and whatever, we're not doing that anymore. Cool. I just got played. He's in love with someone else. It's just a meme, Luna. It's just a meme. Pokey is still the queen, but you know. You know, we can, you know, it's open relationship, right? You give money to me, I give money to Pokey. It's like a cycle. Cycle continues. I think our test will pass, but I'm not entirely sure if we needed this. But we can keep the monitoring reference and we can update that if we want to for the time being. You know, we can just keep this as is. For the time being. This is not how an open relationship works. Disclaimer, donations are non-refundable. You're not purchasing any product or service when you donate. If you want to donate, do it because you enjoy the stream and want to support me. Yes, I put that in because otherwise PayPal does not allow you to to file like to counter chargebacks if people were to charge back. Cool. I think we're good. I think we are good. It's funny how we don't really care about the result of ETS delete, but you know. Oh, they changed their policy already? Oh shit. So it's up to it's for them to prove that they didn't receive their thing or something? I think we're good. Let's just see if the tests pass. That's what we have them for. I think it's gonna break, but 7 failures. Failed to start child with spec viewer game queue manager. Name was not found in empty list. Name was not found in this empty list. Okay. Oh, our registry text. Okay. Changes with the performed above have broken our test because the registry requires a name option when starting up. Furthermore, some registry operations such as lookup require name to be given as an argument instead of PID, so we can do the ETS table lookup. Let's change the setup function. Right. Okay, so this is exactly fixing what we have. Manager test. And then here we need to pass it the name, which is, okay, don't know what this is. Context.test. Fuck is that? Okay, I don't know what this is. They can track because donations mostly go through Streamlabs. Oh, I see. Okay, nice. That's good. Once we change the setup, some tests will continue to fail. You may even notice tests pass and fail inconsistently between runs. What? Compiler, manager test. Unexpected. No. Oh. Is this how you do it? They can try. Oh no, we're just playing around. Rejected? Yeah. Luna always does me like that. You know? It's fine. It's fine. So something is wrong here. Variable context does not exist and is being expanded to context. I don't know what context. Where the fuck does this come from? Oh. Hold up. Hold the phone. Okay. We're onto something. Oh, it is too pure for me. I don't know what that means. Okay, Luna. My heart is still broken. What is this? 3 failures. Okay, let's see if when you refresh, it's the same ones. Removes the queue on crash. Removes the streamer when it crashes. That's a different test. Okay, yes, we're seeing some weird test failing. Why is that? Josh told me you gave him your first time. Josh told me you gave him your first time. Josh told me you gave him. Josh told me you. Josh told Luna that I gave Joshua his first time. True. True. Jeez, that was like, I don't know why it took so long. If you turn off warnings, you never make a mistake. True. True. That's my philosophy as well. Okay, so we don't need manager here. That's why that's gone. So that at least those weird warnings are gone. S is not able to destroy, terminating GenServer stop, blah, 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 bro, boom, boom, boom. S bombs buckets. It may be failing online. Okay, buckets shopping. How can this line fail if we just created a bucket on the previous line? The reason those failures are happening because for didactic purposes, we have made 2 mistakes. We are using cast while we should be using call. We are prematurely optimizing by adding this cache layer. Great. Developing an Elixir does not make your code free of race conditions. However, Elixir's abstractions where nothing is shared by default makes it easier to spot a race condition's root cause. We invoke registry create. The registry creates the bucket and updates the cache table. We access the information from the table. The command returns this. However, since create is a cast operation, the command will return before we actually write to the table. In other words, this is happening. We invoke this, we access information, the registry creates the bucket. No. Okay, this is what we already fixed though. This is not what we have. We don't have this problem. So why do we still have a problem? Oh, there's a trace option. It'll raise condition. Oh, Jesus. Look at the tests that are passing. That's cool. Tests not being able to destroy an already destroyed streamer queue. Test not... Process is not alive. Handle call. Destroy. Oh, so our destroy test is failing. What are we doing in our destroy test? I thought we didn't change any of that. That's the only one that's not in the example. Frick. Destroy streamer, use with streamer, monitor references, get the streamer from the thing. If it does not exist, then we just reply with, queue not found. Otherwise, we stop the GenServer GenServer stop, normal. The process is not alive or there's no process currently associated with the given name. So the PID that we get here is the table, not the queue. That's not correct because we get the PID back. And we create the queue PID and then we insert this into here, streamer queue. New status is this. We do a get queue, we get the queue back, we get okay with the queue, we stop the queue. How is this not working? Maybe by the time we do stop queue, this is already handled. But it fails on here. 69, no? Yeah, 69. Line 69. Nice. I knew that would happen. 69. Fails on 69. Nice. I actually don't understand. Don't really understand what's going on. This didn't fail before. Right, I'm running again. Oh, it's 2 failing tests actually. PID. The ability to destroy a streamer queue. Assert that the manager get queue equals error, but it found the actual thing. In 66. The test file. So here it assumed that the manager get queue call. Yeah, that makes sense because it already, dies before. For some reason, this GenServer stop call is failing. It's like killing the process. I don't know why. Why is that? GenServer dot GenServer inspect. What kind of methods can we call? Debug. Oh no, wait, here are the methods. Where is? Let's try that. This gave us back a PID, but it's supposed to returns the PID or no name node, nil otherwise. So the don't really understand what's going on here. brutal kill. The child process is unconditionally and immediately terminated using process.exit kill. Brutal kill. Okay. In the context of a child. Kind of spooky. Let's think for a second. So we call destroy queue, we give it a server and a streamer name. We then call the GenServer with the destroy call. We receive destroy with the streamer name. We get the current state. The current state is the table reference and the monitoring references map. We then do a case check where we get a queue for the streamer, and we've tried to figure out if that streamer does still exist. Ah, okay. So this is what we're missing. We still need to delete this. So I guess the call... Yeah. This is what I already thought. So there's like double the work here. So actually maybe this is the way. Handle info when I don't know if this call will be too slow, because then we're going inside the GenServer call again. That's what I mean. So I can call this with this, but then like that doesn't make a lot of sense. And in this case, we only have the monitoring reference. So we get the streamer from the pop call. And then we delete it by streamer. So like in theory, yeah, but then this monitoring thing is already deleted. That's me for the last hour. I'm glad we're on the same page now. Low-key rooting for you to figure it out. Let's save and just see what I had before. Yeah. Okay. Yeah, I'm still a bit confused about this duplication. Not a fan. Not a fan. I think this will fix the 2 remaining tests. Yeah. Not a fan of the duplication, but it's fine. Moving shared code to a function. I was thinking about it, but it's like we have a method to destroy a queue, and then you move the 2 methods out into another like private method that share the 2, which could work. But like they're also a little bit different, because here we're, you know, trying to find the monitoring reference by the streamer name, while on this one we're like we only have the monitoring reference because that's like what we get the message from. So it's like it is 2 different sort of like approaches. Like one is delete by monitoring reference, the other one is delete by streamer name, and then it's kind of awkward. So like here we pop the monitoring reference for that specific reference that we get a message from. We get the streamer, we then delete the streamer from our table, and then this one we're like we find the monitoring reference by the streamer name, so like we reverse search, and then yeah, this one is less efficient, by the way. This is just there to make it like hacky work. Yeah, I don't know. I don't have enough knowledge in order to know the right thing is to do. Option is useful when your tests are deadlocking or there are race conditions, as it runs all tests synchronously. Async true has no effect and shows detailed information about each test. Welcome, by the way, Michal. I hope I pronounced that correctly. I don't know. If you run a test multiple times, you may see this intermittent failure. According to the failure message, we are expected that the bucket no longer exists on the table, but it does. Okay, I don't think we will, but... Oh, maybe that is like that because they're only implementing this one. So I think we should also have it. Maybe not in its trace mode. Problem is the opposite of the one that we just solved. While previously there was a delay between the command to create a bucket and updating the table, now there is a delay between the bucket process dying and its entry being removed from the table. So this is a race condition you may not be able to reproduce on your machine, but it is there. Last time we fixed a race condition by replacing the asynchronous operation a cast by a call, which is synchronous. Unfortunately, the handle info callback we are using to receive the down message and delete the entries from the ETS table does not have a synchronous equivalent. Yeah, this is what I said. So when we were implementing the handle call for destroy, it could be like if we just do GenServer stop, that it will fail sometimes, and so other times this will be fast enough, but most times this will fail. Because this message will be sent here and it will eventually process, I suppose. Maybe not. I don't know. I don't know only when this message is called. Maybe when when you're killing it from within the manager, it doesn't. I don't know. Because I think we tested that last stream. So this is what I was saying. Like, this is just like listening to messages which are by nature like asynchronous. It's not calling commands. It's like I send an event out. Like when I die, when my process dies, I send an event out to the people that are monitoring me. And in this case, it's us. And I send a message to you saying, hey, I have been downed. Like, my process has died. Please do whatever you need to do to update your, update your state, or like to do some stuff. Receiving a damage does not have an asynchronous equivalent. This time we need to find a way to guarantee that the registry has processed the down notification when the bucket process terminated. An easy way to do so is by sending a synchronous request to the registry before we do the bucket lookup. The agent stop operation is synchronous and only returns after the bucket process terminates. Oh. The registry may not. In order to guarantee the process of the down message, we can do a synchronous request. Since the messages are processed in order, once the registry replies to the synchronous request, then the down message will definitely be processed. Let's do so by creating a bogus bucket, which is a synchronous request after agent stop. No way, this is actually in the code? What? This is actually in the docs. Maybe I'm... This is so weird, man. This is recommended, you know? That's the weird part. I'm a bit confused. we were not able to reproduce. But like, when we destroy a queue, that's fine. That's like manageable. But like our test here, removes bucket on exit. This one can fail. Yeah, so here we should do a registry synchronous call. Do a call to ensure that the manager process the down message and then assert. One failure. What do you... Oh yeah, we're creating the new string with the same name. Oops. Bogus. We're creating it with the same name. That makes so much sense that it was able to find it. Oh, it still fails. Wait, let's just do not the trace one. Wait, how did it just fail and now it passed when I did like asynchronous? Hold up. Shouldn't it be the other way around? Oh, it did pass. Don't tell me it's still random. Do we have other tests that are relying on this? Like this asynchronous call? Here, stop. Yeah, this one. This one needs it too. Removes the streamer queue when it crashes. Okay. Wait, we already have this test. Removes queue on crash. So we already had a test. Why do I have this test? Oh, this is a shutdown. Okay, let's just put these next to one another. When it soft crashes, and then we have one on hard crash. Code that fixes itself is always nice. I'm a bit scared. I don't know. I don't really know. Removes the streamer queue when it crashes. Oh, it was the one that we did not fix. So we run into the actual issue. Sick. So we run into the actual race condition right before when I switched to like from asynchronous to synchronous. Okay, sweet. We're good. Sweet. Cool. Okay. Cool. Okay, what did we do? I wonder if we should keep this code. Fuck the world, we're gonna keep it. A lot of code. This should be part of it. The rest can kind of stay the same. Use ETS for faster lookup times. Just a performance cache benefit. Instead of using the GenServer internal state, we are using the more performant ETS table, like ETS memory cache. instead of doing the whole event call, GenServer event call. Cool. And then on top we have, okay, let's move these into two different things. Hold up. Now it's getting really hard to read. Let's also maybe create await async. What does this do? Ensure down message send. You give it, what do we need? The manager. Which just creates something with something random. And so now we can get rid of this because the methods by itself already explains what it does. Okay. Let's see. Hey baby, you can call me your code because I want to crash at your place tonight. That's actually really bad, Luna, because that implies that all my code always crashes. It's like a reverse. Like the reverse of what you're trying to accomplish. Hey, do you know any beginner code guides, docs with some assignments and such to learn? If possible in C#, C++, or Java, but any much used languages is welcome. I don't know. I've never written anything in C#, C++, or Java. So I cannot help you with that. But I do recommend people to just go to Codecademy. I mean, that's helped me quite a bit. But he's doing like the Codecademy course, I think, has taught me a lot. But I don't know if it has C and C# and C++, so this is what you need to see. Did you just crash? Isn't Python for beginners? Python, I wouldn't say Python is for beginners, but it is a good starting language, I would say. Yeah. Hey baby, if I was an OS, you would be you would be my priority process. That's a good one. Good one. I wonder if we do an ensure call here, whether we can actually make it work with the down message call, but I don't think it would actually, you know, send a down message. Um. Okay. Do our tests still work? Nice. Okay, let's put this in. Ensure our tests always work due to the async nature of down messaging. The down message sometimes gets received or sent too late, meaning that we already do a call to get queue while the queue was not yet fully deleted. Fully cleaned up. Going to follow up with software engineering in the IT study, and I heard that they use C#, C++, and Java among others. So I'm just trying to learn some basics here. No, I think it's a good idea. What's up, Ruben? Ruben Bond, how's it going? I think it's a good idea. I mean, I benefit a lot from having programming experience before I, did my study. I think it's helpful. I think it's helpful for sure. I just don't have experience with C#, C++, or Java, so I can't help you there. Okay, let's do move the test now, so that we have some nice and clean commits. Cannot create a queue when it's cool. Move test closer to the soft crash case. Already loaded by Code Academy here, so that's a progress. Yeah. Oh. Note that the purpose of the test is to check whether the registry processes the bucket shutdown message correctly. The fact that the registry lookup sends us a valid bucket does not mean that the bucket is still alive by the time you call it. For example, it might have crashed for some reason. The following test depicts this situation. Simulate a bucket by crashing it. Now try to call a dead process, causing a no proc exit. Bucket can crash at any time. Do we want to write a test for this? It's just to show it, right? This concludes our optimization chapter. We used ETS as a cache mechanism where reads can happen from any processes, but writes are still serialized through a single process. More importantly, we've also learned that once data can be read asynchronously, we need to be aware of race conditions it might introduce. In practice, you find yourself in a position where you need a process registry for dynamic processes. You should use the registry module provided as part of Elixir. You find yourself in a position where you need a process registry for dynamic processes. You should use the registry module provided as part of Elixir. It provides similar functionality similar to the ones we build using GenServer plus ETS, while being able to perform both writes and reads concurrently. It has benchmarked to scale across all cores, even on machines with 40 cores. What? This is the programming language of the future, chat. We need like languages that can scale up to more cores, like do more concurrency work, because like cores reach their point of being like optimized, and now you can just horizontally scale, like just by adding more nodes, more CPUs, more cores, more threads. C#? Does C# have it? Probably. C# is a big language. Wouldn't be surprised. I mean, isn't C# owned by Microsoft? .NET. Is C# owned by Microsoft? C# was created by Microsoft for Microsoft. Yep. Okay, I think this ends the piece of the puzzle. So I think since it's already past 12, I think what we're gonna do is we're gonna call it here. And then in the next stream, we'll be going over rewriting our manager to use a registry instead. And I think we already planned on doing that today. But we've learned a lot to use a dynamic registry. So a lot of the work that we're doing inside his manager can probably be abstracted away inside a registry. Elixir registry. Registry start link. Key should be unique. Registry via test. So we call this registry via test. Registry via test. Or not. Name via registry. Registry via test agent. Don't really understand what this is. Well, this is just the agent start link name. Once the registry is started with a given name, it can be used to register and access named processes via the tuple. Oh, you want to play Overwatch? Oh, I gotta go to bed. Work tomorrow. You should go to bed too. Luna, what the hell? Did you send me your Battle.net account? Registry lookup agent. I don't know what this is. Oh, this is the registry name. So we just called it. Okay, so we do registry lookup the name of the registry and then the thing. So in our case, that's streamer. So we're trying to find a queue by a streamer. And then we can start link an agent by passing a via call. So we start a child. So we don't need those two dynamic registries. We can just be managed within this registry, I think. Or not. I don't know, actually. I don't know. No, because I think it still start link on every single instance. I'm gonna sleep. Good night. Good night. GBRLP1. It's a very hard name. I don't know how people pronounce it. I think we might be friends already, but we can add next time if not. Probably, yeah, true. Actually, yeah, I think we've played before. Yeah. Oh! You just changed your name. Jesus, this is such a hard name though. Holy moly. Jesus. Name is so hard. Good to see you, though. Dude, I have no idea what this is. Registry has a dispatch mechanism that allows developers to implement custom dispatch logic triggered from the caller. Okay, yes, I understand. This is like enhancing it. Okay, we will look at this next stream. I think we'll just need to see like how this works. If this is like what we need, or whether the dynamic registry is still like something that we need to couple with the normal registry. I think that's still what it is. I think like the registry just abstracts this work that we do, like monitoring, adding monitoring, and then like this thing. But I don't know. We'll just need to see. Okay, thanks everyone. Let's recap what we've done. So today we have made use of a dynamic supervisor that protects our normal manager, so that if a queue crashes, it doesn't take down our manager completely. We've learned that we can use an observer to check out the current state of our application and the processes within. We have rewritten some of our methods to use the ETS lookup table, which is a very, very powerful concept. It's the Erlang term storage. And so like you can just store data into it. Kind of interesting. It's a memory DB basically. And I think there's a lot of things here, and I wonder if this is like, if this is safe amongst other, because like the thing is, and I think this might be part of the next steps. No, this is umbrella projects, but like Elixir can actually have distributed machines and they still communicate amongst each other. It's very interesting. It's a very interesting concept. So I wonder if that ETS, this thing, is also something that can be shared. That would be very strange. If it like replicates amongst the nodes, you know, like very strange, very interesting. Oh, ETS is local? Okay. Right. Okay. Because what I see here is like repair continuation. Like, okay. But yeah, I think we've touched ETS now. We've touched like the need for like a refactor here. But we have tests, so like we can refactor safely and still have our tests cover our ass. I'm not too big of a fan of this destroy method, for example. Not a fan. But who knows? I guess we'll get there. Yeah, I think that's cool. Learn a lot. So thanks everybody. If you enjoy these streams, I upload all of these streams on YouTube, and maybe eventually there will be like shorter videos or more highlight related videos where we highlight some of the progress that we've made amongst this project. Even though my goal is not really to just go ahead and just, you know, finish everything as soon as possible. I'd rather just learn. But if you're interested, and if you're watching this on Twitch, you can just subscribe to my YouTube. If you're already on YouTube, then I would say just hit the subscribe button if you enjoyed the content. There will be all kinds of tech stuff on that channel. So there might be like soldering or the electrical engineering stuff or whatever tech-wise I do. I just drop it on there. If people are interested, they might, you know, enjoy having this on the side. There might be some content to watch back. I don't know. But I think it's yeah, I think it's nice to just sometimes have a stream on the side while you do your work, you know. And for those people, it's there. Or maybe you've missed something, some part of the stream, and you want to watch it back. At least it's there. All right, thanks everybody, and see you guys next Wednesday if you're there for the coding stream. And otherwise on Monday, I'll be doing, you know, just a gaming stream. And if you want to, you know, join the Discord or you want to join the community, have a chat, you can always message me or just send a message in the Discord. All right, cool. Until the next one.